Day 2. Yesterday you wrote definitions, equations, what was the other word? Rules, right?
Yeah.
Okay, it's all the same thing. You were using your a sub n equals a sub 1 plus n minus 1 times d, right? And you found different parts of that. Now, those were explicit definitions because I can plug anything I want into that, right?
Yeah.
Everyone, what's this? This is going to go into the American Sign Language book. What does this mean?
Your nose.
Put your mask over your nose.
I don't have your mask on.
I'm far enough away from you, and I can do it when I'm lecturing. Okay, so this is not explicit. This is what? Does anyone remember? Because we did it 9-1.
Implicit.
No, close. Recursive. Okay, recursive. Remember, we see these. How do I know this one's recursive? Because it gives me an initial condition, right?
Yes.
And the equation looks funny down here.
Yeah.
So this one says I start at 72, and what am I doing to every term?
Minus 6.
Minus 6. So the first term is 72. So the next term is what?
66.
66.
60.
60.
54.
Why do I have a pencil on the back?
48.
Here's go sharpen. Christmas. No, that's winter. Christmas. Winter is Christmas. Okay, and then 48, right?
Yeah.
And keeps going, yes?
Yeah.
Okay, so we're going to have recursive definitions as in arithmetic as well as explicit. The value, would you rather recursive or explicit? What? Explicit, why?
I think it's
You think it's easier? I think explicit's easier because I can plug in whatever number I want and get it out, right?
Yeah.
Now, if I'm doing explicit and I start and I need like 6 numbers in a row, the first one I'd plug in and the next time I'd probably just like subtract 2 or whatever if I saw it, which I'd be kind of incorporating both. But explicit lets me find something individually by itself. Recursive, I have to find everything, right? Again, when I see these, I look and say, where do I start? And then what do I do to get to the next one? Could that be times 2 minus 6?
Yeah.
Yep. It could be just do whatever it says. Okay. That's all I got on that. Ooh, that's backwards. We did that yesterday. Okay. Our learning goal today is to find the sum. This is another equation. Every day you're going to get a new equation. And you have to know that equation. So I'm breaking it 1 equation a day. Sound good?
how many days?
5 days. There's 5 equations. So there's 1 equation every day this week. Okay? So, yes, you do have this one. It's just a short quiz. Okay, the sum of a what?
Finite.
Finite. What does finite mean?
It's not infinite.
It's not infinite. It stops. Why can we only find the sum of a finite arithmetic sequence?
Because otherwise you're going to have your numbers keep going because they stop.
Yeah.
Your numbers never stop.
Your numbers never stop in an infinite, right? Yeah. But can I make an infinite series or sequence finite?
You can find a partial sum.
Yeah, I can find a partial sum. Those are the words that were messing you up before, right? Partial means just part of it. So this equation is this. S of n means the sum of these terms, the sum of the number of terms, okay, equals the number of terms divided by 2 times the first term plus the last term. Now this a sub 1 does not mean when I plug in 1. It just means whatever your first term is. Make sense? Because you could find it from 10 to 28. Now, I'm going to tell you where this comes from. One day, I forgot to look up his name. Can't remember his name. About a 3rd grade level, 4th grade level, this it's a famous mathematician. I can't remember his name. Anyway, had a tutor. Back then, everybody had tutors. Okay, you didn't go to school unless you went to university. And his teacher did not want to deal with him that day. Didn't want to deal with him. Go over there and add up the digits to 1 to 100. 3rd grader, that should take them like half a day, right? Add them up. Go, get out of my hair. I don't want to deal with you. So he sits down and he's like 1 plus 2 plus 3 plus 4 plus doesn't write them all out, but then goes 100 plus 99 plus 98 plus 97. And he's like, there has to be a better way to do this. I do not want to add all this crap up. Well, what does this equal?
101.
What does this equal?
101.
What does this equal?
101.
What does that equal?
101.
What do you think every single pair equals?
101.
101. The first plus the last.
And 50 of them.
And there's 50 of them.
What?
So
Do this,
50
Brent.
times 101 is 0505. So if you add them all up,
It's like all.
you get 5,050.
And he did this as a third grader?
Yeah, it was about a third grade level.
And he figured this equation.
No, he didn't figure that, like, he didn't prove that equation, but that's where it came from. He did later in his life, he proved it, but that's where he first, that's the first acknowledged, okay, I guess I should say, he proved it later in his life, and his background, that is the first time he observed it. Maybe others observed it, but no one else proved it.
Got it.
Okay, so you don't get credit for it until you prove it. Now, if you notice, guys, that's how I add everything up here. Everything all year that we've had to add up, I pair it like that. Only if it's arithmetic, though. Doesn't work if it's geometric or there's other patterns going on. But I group things that equal the same. I'll say, oh, that's 25, and that's 25, and that's 25, so that's 75. I'll group them like that. It makes it quicker. But do you see where this comes from? The first and last term, right? And the 100 divided by 2 is 50, because there's 50 sets. If it's odd number, then you get like 7 halves, right? And you hope what it adds up to is even, so you can reduce and then multiply. But not a very hard equation to remember, I wouldn't think. Would you?
No.
So S stands for what? Sum. N is the number of terms you're adding.
Yes. And then
So N divided by 2,
yes.
because we have pairs of things.
Times the
First.
first number plus the last one.
First plus the last. And you remember it's plus because these are arithmetic. Okay? Now, obviously, if one is positive and one is negative, you're going to subtract them, correct? But it's just the combination of the two. So every time you use this formula today, write it so you know it. And then tomorrow when I add another one, it won't be a big deal, right? Nope. Okay, so the sum of 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Is it arithmetic, first of all?
Yeah. Goes
Why?
up
What's
back.
my difference? 2. So I
It'll
want
say-
S of what? How many things are being added?
10.
10? So S of 10. So it's, oh, we didn't write our formula. So S of N equals what?
And over 2.
And
N
over
over
2
2.
times A1 A.
Yes, bless you. Okay, so what's N?
N is how many are there?
And
10
how many
over
are there?
5, 10 over 2.
10 over 2. First term,
1.
1.
last term.
19.
So I get 5 times 20.
1.
Or you could take 20 divided by 2 is 10, and 10 times 10 is,
Good job, guys.
right?
Now, I went way too fast. You're right.
What?
But I just
Oh.
did, yeah.
Okay.
I was right.
Now, we just did the sum of the integers from 1 to 100. I showed you them, right? But we're going to use the formula. Okay? In your assignment today, it's like, it says, it asks things like the sum of the first 50 even integers, things like that. So you have to think a little harder. Okay, so S of what?
And
N.
over 2 times A to the first.
A sub 1 plus A sub N. Don't say 2 though, because then that's the exponent. Not an exponent. Okay, so what's N?
N is
100.
100.
So 100 over 2.
Let's figure this one
And the first term is 1.
Plus 100
So I get 50 times 101.
505.
Okay, go back like 2 slides, I think.
I'm gonna live to
Wait,
that year right
first,
there.
you have S to the,
I'm gonna live
or,
to that.
10 up there?
S sub 10.
I thought it would be, oh, it's because there's 10 of them.
Yep. 2 slides?
Well, maybe this one. That one. Oh, never mind. Okay, go back.
Okay.
I'm this left.
Okay, so write as summation notation. Now, summation notation we talked about yesterday, right? It's just the definition, just a summation and a definition, right? It's nothing else. When it says summation notation, what do you put in there? A sigma,
Definition.
right? A sigma, and a definition. And you need a lower limit and a upper limit. That's it, and an index. Okay, so it tells me write summation notation to find the indicated nth partial sum of the arithmetic sequence. So, I probably need to find a definition, right?
Yeah.
And if it didn't tell me on the test, I'm not going to tell you it's arithmetic. Because there's going to be arithmetic and geometric, and you have to figure it out. You don't know what geometric is yet, but you do know arithmetic. How would I know this was arithmetic without telling you?
It's even.
They all go up by the same.
They all go up by
Four.
4, so D is 4. So, write yourself an equation. Use your skills from yesterday.
Wait, how'd you find D is 4?
Just from -6 to -2, -2 to 2, 2 to 6 is 4. Okay, did you get 4n minus 10?
Yes.
So, I wrote a definition, and now it says use sigma notation.
How'd you do that?
How did I do what?
How'd you get 4 and minus 10?
Because you have -6 plus n minus 1 times 4.
Are we doing yesterday's equation?
Yep. We're not doing we're not doing today's yet. Because it says use sigma notation, so I have to write it in sigma notation first. Okay? So now we have a definition, yes? Right there. So we have the sum, and let's use an index other than n, just because n is going to be I. So I equals 1 to what? 50
4 and minus 10.
of not n anymore because we changed
Four.
for I minus 10. Okay, so this is the sum. Now the sum equation is S sub n equals
N over 2
n over 2
times A
sub 1.
sub 1
Plus
A sub n.
Okay, so that's my equation that I'm going to use to find the sum of this, right?
What do you need to be
Okay.
I?
N is the number of things I'm adding. I is, listen. N is the number of things I'm adding. I is what I'm putting in. Okay?
I think that's
So-
why we changed it.
Yeah, that's why we changed it here.
A sub 1 is -6, right?
Yeah, but I want to show you something. Okay. -6, you get this by looking at this, right? Because you see it. But what happens if I didn't give you this? What if I just gave you the summation notation? How do you find the first term? You plug in the what? Lower limit. So A sub 1 is equal to the lower limit in the formula. Make sense? Okay, so if I plug in 1 here, I get 4 minus 10, which is what? -6. But you need to remember that a sub 1 is plugging in the lower limit. Got it? Okay, so I need n over 2. So from 1 to 50 is how many things? 50. Not gaps, things. Does that make sense?
Yeah.
So if I had 2 to 50, how much would that be? 49. Subtract 50 minus 2 is 48, right? And then add 1 back. Because we're counting things, not gaps. When you subtract, you count gaps. Okay, so 50 over 2. A sub 1, we plugged in the lower limit and got what? Negative 6. Now a sub n, guess how you get it?
Plug the higher limit in.
The upper limit.
So 50.
So 50 is the upper limit. Yes.
Why is it over 2?
This was-
You guys didn't catch that spelled formula. Why is it over 2? Because that's the,
Oh, I didn't realize.
you're doing pairs, remember?
Yeah,
We did
yeah.
pairs. Okay, so if I plug in 50, so 50 times 4 is
200.
200 minus 10, 190. I'm not going to divide 50 by 2 just because I think that it would be easier to divide this by 2. So this would be 184, right? Divide that by 2 would be 92. So then multiply times 50, so 0, 4, 6, 0, 0. I did that right? So 0 here. And then 5 times 2 is 10, carry a 1, 5 times 9 is 45, plus 1 is 46.
Okay, so n is 50?
N is 50. N is the number of things you are adding together.
There's not 50 in negative 6 to negative 2 to 2 to 60 to 6 to...
Dot, dot, dot.
I
And
know,
then
but there was 50 of them?
if this goes, what does this mean?
It goes infinity.
It goes for infinite. I could ask you for the 100. I could say N is
How did we get
100.
an answer?
How did we get an answer? Because I only want the first 50.
So we put 50 for amount of terms.
I only want the first
Oh,
50.
n was... Never mind.
You good? Okay. I can't find just the sum, can I? But can I find the partial sum? Yeah. I can't just, when we do geometric, we will be able to find the sum of an entire geometric sequence if something special happens. And you just put an S, meaning the whole sum. But arithmetic, you can never, ever, ever, ever. Why? Why not? Why can't I find the sum of the whole series?
Because it continues going.
It continues to positive infinity or negative infinity. Why does it keep going back? Okay, write the summation notation and find the indicated partial sum of this. Try this one on your own.
I don't know what D is.
How do I get from 75 to 70, 70 to 65, 65? Yep.
You always put your I to 1. Like when you're writing out the sum.
When you do your own, yes. You can do it to 0 if you want, but when you're doing your own, always do 1. They will give you some already in summation that won't be.
I would be equal to 75, right? That's the first term. No, 1.
I was 1. Because you plug in 1 to get 75. Okay, so did you get 80 minus 5i for your definition?
Negative 5i plus 80.
I got 5 on.
I got 5i plus 7.
Yeah, same.
I got 5i plus 80.
It's because it's a negative 5 not a positive 5.
It's in,
It's a positive 5 and a negative 5.
Well, the D
Oh.
is the negative 5.
the D is negative 5.
I had plus.
Yeah.
I
Yeah.
put
It's not, you're not adding 5,
Yeah,
you're
that's
what?
messed my whole thing up.
Subtracting 5.
I put I and then on accident.
And if you put N, that's fine. I'm just trying to distinguish
Okay, yeah,
between
never
the
mind, I
two.
didn't get 80.
Okay, now when you do like the
Okay, so now I'm going to do the sum, right? So S sub N equals N over 2 times what?
A1 plus
A sub 1 plus A sub N. Okay, so what is my N?
25.
25, because 1 to 25 is 25 things, right? So I have 25 over 2. I get A sub 1 by plugging in the lower limit. So 80 minus 5 is 75, and that's what we were told, right? So we make sure it's right. And now I have to plug in
25.
25. So that would be negative 125, right?
Yeah. Plus 80.
So
How did you
negative,
get negative 125?
Negative 45.
Because
you plug in 25 right here. For I.
What's negative 125?
So negative 125, so negative 45.
So with negative 125, you just added. I don't know what you did.
I have 80 minus 125.
You said 40.
Okay, I'm not dividing 25 by 2 because I don't want to deal with the decimal. Hopefully my other number's even.
So we can just divide 50 or 30.
So this is 30, right?
So we take 25 times
So
15.
30 divided by 2 is
15
15.
times 25.
So I'm going to have 25 times 15. So 25 times 10 is 250. 25 is 125.
375.
So 375.
I did that in my head. I'm proud.
Good day.
So again, how do I find A sub 1?
You fill in the
The
lower
first
you.
lower limit. How do I find A sub 2? I mean A sub N. Upper limit.
So
Into the formula, right?
Yep.
Yes.
But
lower limit's
to
always
find-
gonna be 1, right?
When you write them, you will always put them as a 1. They will give you other things. They will give you, let's do the sum. They would give you sum of I equals 4 to 25 of 80 minus 5i. Okay, same formula.
So it'd be 80
So
plus-
n would be
80 minus
25 minus 4 is 21 plus 1 is 22. Again, we're counting things, not gaps, because you have to count 4. So we have 22 over 2. How do I find A sub 1?
Plug in the first
Wait.
letter
Plug in
number.
4.
Where'd you get the 20? Plug in 4 for what? Both of them? I thought it was just the first number in.
Okay, I changed it. I changed it from 1 to 4. I changed it.
Should be 60.
So when I plug it in, I get 20. So 80 minus 20 is 60.
Can't you just look at the?
Okay, I didn't give that to you. Didn't give it to you. I should have given you 5. instead. I was trying to, this does not exist when they give you a problem like this. Okay? How did I get the 22? I took 20, upper limit minus lower limit plus 1 is 22. That's how you know how many things you're adding. Okay? So then I plug in the upper limit. We already found that was what? Negative 45. So then I have 11 times 15 is 165.
Wait, what number below that 21 on the left?
Plus 1. See, it keeps writing wrong.
Where did the plus 1 come
Okay, when you, okay, 4 to 10. How many numbers is there?
6.
Okay,
from? 5.
there's 7. 4,
Oh, 4.
5, 6, 7, 8, 9, 10. When you subtract, you are finding the spaces between. Are we finding the spaces between? No, we want to know how many things there are. Okay? So if you subtract, that's fine, but you have to add back in 1 for the first term. Does everyone understand what I'm saying?
Yeah.
Because if I say from 4 to 10, there's 6 gaps, right? 1, 2, 3, 4, 5, 6. But how many numbers is from 4 to 10?
Okay, I got it.
Got it? Okay. So these are some we could use our rules on, if we remember them. Hopefully you do. Okay. And it says find the indicated partial sum because these are infinite, and so we're going from 1 to what? 100. Does anybody remember what I can do with that too?
You can divide it.
You can put it in the front.
I can put it in the front.
That's what I said.
So then I have 2 times the sum from n equals 1 to 100 of n. What?
Doesn't that make it pretty simple?
Yes.
'Cause we already know what the sum of
We already know it, but if we didn't know it, we'd use our formula, right?
Yeah.
So our formula then, we're going to use n over 2 times a sub 1 plus a sub n, right? So we're going to have 2 times, well, from 1 to 100 is what?
101.
101.
101. Oh, wait, from 1 to 100 is not.
Oh,
When you start at 1, it's just 100. When you start at 1, it's just what it is.
100.
100 over 2, right? Times the first term. How do I get the first term?
You put in your
Lower limit, so I get 1. A sub n, I put in my upper limit, so
101.
this is 50. This is 101. So this would be 100, right? 2 times 50 is 100. Yes.
100
Yes.
times 1.
So 10,100.
I don't like the way that number looks.
Again, I didn't have to do that, did I? I could have used the formula the way it is, and it wouldn't have broke it down. It was simpler this way. Same problem, yes, but I'm multiplying by what this time? 7. So it's 7 times the sum from n is 51 to 100 of n. So 7 times, now 51 to 100 is what? 49 plus 1 is 50. So I have 50 over 2. What's my first term?
51.
51. What's my last term?
100.
Okay, so this is 151, right? And this is 25 times 7. So 275, right? 7 quarters would be, no, how about $1.75? 7 quarters would be $1.75, right? Okay, so we need to do 175 times 151.
Where'd you get the 50 over 2? 26,425.
26,400 what? 25.
Did that in your head?
Obviously.
The 50 over 2 is 100 minus 51 is 49.
Yeah.
Plus 1 is 50.
Wait, oh, that's not-
Because,
Do you not understand? You did go through
No, I
that.
understand it, it's just like this part right now, I'm having like a brain fart for some reason.
okay, right here, this is how it works. From 4 to 10, there are 6 gaps, yes? But how many numbers are there? 7. So if I were to take 10 minus 4 is 6, plus 1 is 7. You always have to add back in your first term. Because when you subtract, you're only finding the gaps.
There's 49 counts, but you got one.
Yep. Okay, there's 49 gaps, but there's 50 numbers, right? Okay, do I put these together, or can I do them separately? Can I do them separately? Yep, separately and subtract?
Yeah.
Okay, so from this one, I'm going from 11 to 30. And this one, I'm going from 1 to 10.
So 10 and
So
20.
here, from 30 to 11,
20.
20?
21.
Yep, 20.
So 20 over 2. My first term is what?
11.
11. My last term is
30.
30. Minus. So 1 to 10 is?
I did that one.
1 to 10 is 10 over 2. First term is
1.
1. Last term is
10.
10. So this is 10 times 41, right? Minus 5 times 11.
So 410 minus
410 minus 55.
355.
355.
That'd be 65.
No, because you had to borrow to make it 10. You had to borrow to make it 10. I'm pretty sure.
No, yeah.
How did you get the 20 over 2?
Because, okay, 30 minus 11 is 19.
Okay.
Plus 1 is 20.
I forgot why you plus the 1.
Because when you subtract, you're finding gaps. We want the actual terms.
So there's 19 gaps.
There's 19 gaps, but there's 20 numbers. I think that's it. That's it. That is it for today.
Can I go to the right?
Yes, you may. So what's your formula you need to learn today?
And over
Sum of n and over
Equal n
2,
over 2.
a sub 1 plus a sub n.